Just imagine I am giving you a full glass of acid and ask to drink that acid. What will happen to you? If you are drinking a glass of acid, completely full glass, say around 200 ml acid you are drinking, what will be the result in your mouth, your stomach? What will happen to you? Obviously, answer is depend upon what is that acid. Suppose I am giving you lactic acid, that means buttermilk, you will get very good. If you are liking out, then very good feeling. If I am giving you solution of citric acid, that is lemon juice, then also there is no problem. So like that, if acid is there, then we can consume that. But suppose I am giving you hydrochloric acid to drink, then obviously it is very, very harmful. If you are consuming sulfuric acid, it's very dangerous, and nitric acid is still dangerous. So we have to find out what is the difference here. Why certain acids we can consume and why not other? The reason is there in the nature of acid and strength of acid. Now first thing we have to discuss here, that Arrhenius is saying that substance when dissolved in water, ions are produced. Substance can undergo dissociation and ions are separated. Many times polar substances are forming ion, that means they are undergoing ionization. But the extent is different in everywhere. It is not mandatory that suppose our substance, okay, henceforth we are using some different terminology. Every time I am not giving specific acid name or basic name. So we have to generalize. As we have discussed, that Arrhenius concept is having several drawbacks, but still we have to accept that Arrhenius concept because we are dealing with aqueous solution maximum. So according to Arrhenius, substance which donates H plus ion, that is called as acid. So I have to write down acid as Ha. Why I have to write down acid as Ha? Because A is any substance. H is having positive charge and A should have negative charge. So on dissolution, Ha will give me H plus and A minus. So this is called as acid because it is giving me H plus ion. Same way base, I can write down this way, BOH. Why BOH? Because on dissolution, it will give me B plus plus OH minus. So as OH minus is donated, this substance is called as base. So generally we are calling acid as Ha, base as BOH. Then salt. Now try to recollect. Acid react with base to give salt. So this B is positive and A is negative. Plus water, that is H2. You can find here this is salt. So what is my salt? Generalize, I can write down salt as Ba. Ba when dissolved in water, it will give me B plus and A minus. So this is salt. So I am having acid, I am having base, and I am having salt. So keep in mind, this way we can remember the names of acid, base and salt. Considering this acid, our name of acid is Ha. I am dissolving this acid in water. That will give me Ha plus H2. Reversibly, I should get here H3O plus plus A minus. Now, this is true, but suppose 100 molecules of Ha are there, then it is not necessary that all of them undergoing this reaction. May be possible one molecule is undergoing reaction. So it will react with one molecule of water and H3O formation is 1 and A minus formation is 1. 99 molecules will remain as Ha only. They are not taking part in the reaction. That means dissociation is there, but all molecules are not dissociating at a time. Few molecules can undergo dissociation, few molecules are not undergoing dissociation. Suppose Ha is there, then sometime all 100 molecules also can undergo reaction. Sometimes 50 molecules are undergoing reaction. That means extent of dissociation is different. That extent is called as degree of dissociation. So first term we have to use here, that is degree of dissociation. Degree of dissociation is denoted by letter alpha. This is called as either degree of dissociation or degree of ionization also. So this is alpha, that is degree of dissociation, that is fraction of total number of molecules undergoing dissociation. I am writing in short way, I am revising, it is fraction of total number of molecules undergoing dissociation divided by total number of molecules present. Alpha is given in terms of percentage. So I have to take multiplier as 100 and I have to give answer as degree of dissociation as something percent. Now let us check out here. Suppose one molecule is undergoing dissociation out of 100. Then this will be 1 by 100 multiplied by 100. 100 will get cancelled. Answer will be 1%. So alpha is 1%. That means one molecule is undergoing out of 100 dissociation. If alpha is 100%, that means all molecules are undergoing dissociation out of all molecules. So alpha is 100%. So this way, first thing we have to consider that all molecules are not undergoing. Again, take that reaction that HA is giving H plus plus A minus. Now I am not writing purposefully that H3O plus again and again. Actually that is right concept, but we are discussing on basis of H plus now. We have to understand where H plus is there, that should be H3O plus. Now this is having alpha. Alpha means degree of dissociation as 1%. That means 100 molecule, 1 is undergoing dissociation. So 99 is remaining. Here it will be 1 and 1. So initially there will be 100 molecules and ions formed are 0. But when we are waiting, that is dissolving in water, we are waiting for some time, then rate of forward reaction will be equal to rate of backward reaction. That condition is called as equilibrium condition. And at equilibrium condition, you may find that one molecule is undergoing dissociation. So 99 molecules are remaining as it is. One molecule is undergoing dissociation in form of H plus and A minus. Therefore, number of H plus ion form 1. And this is also 1. Don't tell me 1 plus 1 equal to 2. Here we are writing 99. The reason is that one HA is undergoing dissociation. Therefore, we are getting 1 H plus and 1 A minus. So we are writing out number. So out of 100 molecule, 1 is undergoing dissociation. So this will be 99. Actually, I am writing in bracket 100 minus 1. So we are getting 99 molecules and 1. That means reaction is reversible and there exists a constant that is called as equilibrium constant. We are applying here law of mass action. So what is law of mass action? That equilibrium constant is equal to multiplication of molar concentration of product divided by multiplication of molar concentration of reactant. We are not writing out water in this case because we are not writing out H3O plus here. If you want to write down H3O plus here, then you have to add water. But that will increase my trouble. Instead of that, I am keeping in simple way this. So this is called as law of mass action, and this constant is called as equilibrium constant. Now this equilibrium constant is for dissociation of acid. So I am writing out this equilibrium constant as Ka. This is called as dissociation constant. So as alpha we are calling as degree of dissociation. So here we are calling this as dissociation constant. So Ka is dissociation constant of acid. So for acid we can use this equation for dissociation constant. So Ka equal to concentration, molar concentration of H plus into molar concentration of A minus divided by molar concentration of Ha present at equilibrium. This law is applicable practically when equilibrium condition is there. Now it is obvious, we can classify simply this way. If K value is greater than 10, then acid is called as strong acid. If K value is less than 10, acid is called as weak acid. So simple thing, if you are considering finding out the K value is greater than 10, we have to call that acid as strong. If K value is less than 10, we have to call that acid as weak. Now in weak acid, there are again conditions. Moderately weak, moderately strong, like that conditions are there. But in order to keep in mind very easily, I am giving you only simple thing. The value is depend on K. If K value is greater than 10, we have to consider as strong. Remaining all we have to consider moderate strong, moderate weak, whatever. But they are not strong. So we can classify as strong and not strong. So if K value is greater than 10, it is strong. If not greater than 10, it is not strong. Now suppose alpha is 100%, then just check out that HA will be 0, H plus will be 100 and A minus will be 100. So if I am substituting these values, then I am getting K value as 100 into 100 upon 0. Anything divided by 0 is meaningless or infinite, and you are aware that infinity is greater than 10. Therefore, if substance or acid dissociates to 100%, then we have to call that as strong acid. And therefore we are calling particular acid, if it is dissociating to very great extent, then we are calling this term as that acid dissociates to almost 100%. We are not using the word 100%, but we are using the word that dissociates to almost 100%. If you are very good in mathematics, then we can apply term of limit over here. We can say limit as alpha tends to 100%. That is, alpha is very close to 100, but it is not equal to 100. If it is equal to 100, then denominator certainly goes for 0. If it is very close to 100, that means denominator is very close to 0. But that is not meaningless. That is very great figure. And therefore, strong acids are having Ka greater than 10. Now, Ka. Same way, try to find out value for Kb. For this purpose, we have to take a base. So my base is BOH. BOH will undergo dissociation as B plus plus OH minus. Now, as this is giving B plus and OH minus, I am having again that same thing. Initially, let us check out. Now we are using different language. Initially, there are X moles of BOH. Then number of moles. I am not using word now molecule. We are using moles. Moles means what? Molecular weight expressed in terms of gram. 1 mole corresponds to 6.022 into 10 raised to 23 number of molecules. So initially suppose X moles are there. Then we are having B and OH, that is in terms of 0. But at equilibrium, now try to recollect, one molecule is dissociating, so we are writing out 100 minus 1. So same way I can write down whatever alpha that we have to subtract here. That is the number of molecule undergoing dissociation. So X minus alpha is the concentration of, is the amount of BOH present. B plus dissociated and OH minus dissociated is equal to alpha. Therefore, if alpha is not equal to 100%, then only these laws are valid. So whatever we are writing out, that is valid when alpha is not equal to 100%. Because alpha is equal to 100%, then X minus 100% means X. So this term will become 0 and our term is meaningless. So we can write down alpha 10 to 100% is allowed, but alpha equal to 100% is not allowed. Now here I can apply law of mass action here. So K equal to concentration of molar concentration of product multiplication of molar concentration of product upon multiplication of molar concentration of reactant. As this is base, so I can write down name for this constant as Kb. This is called as dissociation constant for base, and B plus into OH minus upon BOH. So this is about base. Now try to write down same thing for neutral salt. That salt is Ba. So I can write this way, that will give me B plus plus A minus. Then initially X moles are there, 0, 0. Then 100%, alpha is not equal to 100, therefore I can write X minus alpha. Here that is giving alpha and alpha. So as alpha is not equal to 100%, I can apply law of mass action K, that will be equal to molar concentration of B plus into molar concentration of A minus upon concentration of B. Here I am not writing A or B because this is neutral salt, so this is dissociation constant for salt. So this way we can write down dissociation constant for base and dissociation constant for single salt. So just take down these all equations. Now, in order to carry out further derivations, no doubt we have to carry out certain derivations here. These derivations are very, very important. These derivations are very easy, not much difficult. But in order to understand, you must be thorough with these concepts. So try to revise this first. Try to revise it twice, thrice. Make clearly in clarity in concept, and then observe further lecture. That lecture will give us Ostwald's dilution law, that is relationship between alpha and K, either Kb, Ka or K. Keep in mind, Ostwald's dilution law is applicable for weak electrolyte only. For strong electrolyte, Ostwald's dilution law is not applicable. The reason is that for strong electrolyte, we can consider alpha equal to 100%. If alpha equal to 100%, then denominator always goes for 0. Then we are getting no value of K, that is meaningless or infinite, and therefore Ostwald's dilution law is applicable for weak electrolyte only. So in next lecture, we are going to